So now we come to another numerical. Now I'll first read the question for you. A ship of 3000 ton displacement is 100-meter long. Now this ship is 100-meter long and the displacement is given. Now it has got a km value. Now I hope these terminology are clear for you. I'm not going to explain it to you all these terminologies. Okay. Km value is given to be 6 meter. Kg is 5.5 meter. Okay. Center of flotation is 2 meter. Center of flotation is 2 meter aft of amidship. Now the MCTC. Okay. Now for those, just let me recall. MCTC is what? Moment to change trim by 1 centimeter. GM is what? Metacentric height. M is what? Metacenter. C is what? Center of gravity. B is what? Center of buoyancy. Okay. That we are gonna discuss. Find the maximum trim for the ship to enter a dry dock of metacentric height at a critical instant before the ship takes the blocks forward and aft is not to be less than 0.3 meter. So now first of all we'll see what all we have been given over here as per the question. If this we write now, then question becomes easy for us to solve. Okay, now 3 tons. L is given to be 100 meters. Now the value of km is equal to 6 meter. Now the kg value is 5.5 meter. Now the MCTC is 1 centimeter, 40 tons meter. Okay, center of flotation. Now the center, I'll write here center of flotation C of 2 meter aft of. Now this symbol denotes midship. Okay, so the aft of midship. Now the virtual GM is also, GM value is also given, and it is how much? It is 0.3 meter. Okay, now we draw this diagram. Always we need to draw, okay, so that it becomes clear for you. Now this is what we describe. Now here, as I told, this is the midship position. Now this is the K, that is keel. Okay, now this is B, this is G, and this is metacentric height. Now originally what we know is GM is equal to km minus kg. Now the value of GM, how you will get? Km minus kg is equal to GM. Okay, so here it what will be? 6 minus 5.5. so GM value will come out to be 0.5 meter. Now the virtual GM is 0.3 meter. Virtual GM is 0.3 meter given. So how much we have virtual loss of GM? So virtual loss of GM we calculate, and it is 0.5 minus 0.3 is equal to 0.2 meter. Okay, now there can be n number of method to solve this. Okay, so first of all we go and see. Now see, virtual loss of GM is equal to m into km upon delta. Okay, now this we have calculated. It's 0.2 is equal to m into 6 by 3000, that is displacement that is given to us. Okay, so the value of m will come out to be 100 tons from here. M is 100 tons from here. Now we calculate what is known as is change in trim. Now when we calculate change in trim, the formula, what we denote is what is known as m into d by MCTC. Okay, now this is what we know as trimming moment. This is what is known as trimming moment. Please bear with my handwriting. Okay, now this is what is known as trimming moment. So therefore D is equal to L by 2 minus LCF. Okay, so now here we put 100 by 2 minus 2. Now what we have been given here is LCF is equal to 2 meter aft of amidship. Amidship. Okay, now here is m is what is mass, and d what we calculate is now the distance from center of flotation to aft. Okay, so now here we get, as per this formula, d comes out to be 48 meter. So therefore what we calculate is change in trim. So for change in trim, when we want to calculate, it will come out to be 100 into 48 by 40. So it will come out to be 120 centimeter by stern. So now d here what is known as distance of from aft. So there can be a separate method as other way also. So if we wanna go for second method also, so we calculate. So another method what we known, see, directly we calculate virtual loss of gm is equal to m into kg by delta minus m. So now here we have 0.2, virtual loss of gm is given, m into kg is 5.5, and then here we have 3000 minus m. Okay, so it will be 0.2, 3000 minus m is equal to 5.5 m. So here therefore we have 600 minus 0.2 m is equal to 5.5 m. So we have 5.5 m plus 0.2 m is equal to 600. 5.7 m is equal to 600. M is equal to 105.26 ton. So here, and directly now we can calculate what is known as change in trim. So this method seems to be change in trim when we calculate. So it is m, same, m is the mass, d is the distance by which it is the object is moved, mctc, and then we have 105.26 into 48 divided by 40, and there is a slight difference in the answer. There we found out to be stern, it is 120, and here we come 126. So as per method 1 what we calculated, it was 120, and now what we calculate is 126. Okay, now see, although effective gm is same in both cases, the writing moment at some angle will not be the same. So writing moment will not be the same. Effective gm remains the same in both the cases. Okay, thank you so much.